Using basic properties of logarithms. This is your new objective for this week. You will have a test over all the various properties that we go over on Friday. So you have Monday, Tuesday, Wednesday, and Thursday for intervention if you so need that help. Here's the first one. Basic things you have to know is that the setup for a log is just a different setup for an exponential expression. At the top you have the log. Log base b, this is the base, of some number that is the result of something taken to a power. And it equals that exponent. In other words, b to the y power equals x. B here as the base, whatever that number is, you're raising it to this power out here and coming up with a result, x. The way you read it is log base b of x equals y. It's just another way of writing b to the y power equals x. There's two different types of logs. There's a common log, which is just log. There's a button for that on your calculator. If you see the word log, but there is no base written with it, then the base is automatically 10. Common logs have a base of 10, if no other base is written. And then ln is a natural log. There's a button for that on your calculator too. If there is no base, it is e. And e is approximately 2.71. This is used in financial calculations, like compound interest and items like that. Common logs, base of 10. Natural logs, a base of e. E is kind of like pi. Pi is 3.14. E is 2.71. So we have log base 3 of x equals 3. You can solve a logarithmic equation for any one of those positions, and it just so happens that x is missing now. If you remember the setup for a log, then you can look at it and know that 3 to the third power equals x. And come up with the answer for x. Just type it in. 3 to the third power is 27. Log base b of 25 equals 2. So if you remember the setup for a log, then you would know that b to the second power equals 25. So some number squared is 25. And of course that one's very easy to figure out, but if you did not know that, then what you would do is undo the square on the b squared by doing this. Square root, square root. Square root of b squared is b, square root of 25 is 5. Log base 4 of 64 equals y. You should know that that means 4 to the y power equals 64. Now you may be able to figure this one out. It's an integer exponent. But if you can't, and you will get some that you cannot just look at and come up with the solution for y, then you should know how to do this. And the way you would solve an exponential equation like this is to take a log of both sides. So log of 4y, 4 to the y power I should say, and then equals log 64. So you put a log on both sides. And then next, there is a property of logarithms that says whenever you have the log of something raised to a power, such as y, you can move that power to the left-hand side of the log and make it a coefficient. Move this out to the left, the exponent. And then once you do that, you can solve for that y by dividing the right side by the log 4. So in your calculator, you're going to type that in. You're going to type in log 64 and then a right-hand parenthesis and divide by log 4, right-hand parenthesis. And what is the answer? 3. You have log base 2 of the quantity x plus 6, close the quantity, equal to 5. If you know the basic setup for logs, then you should know that that means 2 to the 5th power equals x plus 6. Solve for x. I can keep x where it's at and move that 6 to the left. Change the operation. 2 to the 5th power is 32. If I take away 6, I get 26. 2 to the 5th power equals the quantity of x plus 6. 2 to the 5th power equals x plus 6. Move this 6 to the left, change the sign, simplify 2 to the 5th to get 32. 32 minus 6 is x. That's going to be 26. Log of base x plus 2. Log base x plus 2 of 625 equals 4. You should know that that means x plus 2, the quantity of x plus 2 to the 4th power, equals 625. Now, don't multiply this out. Don't do x plus 2 times x plus 2 times x plus 2 times x plus 2. You could, but you're going to be wasting your time. Because what you need to do to undo all this and just be left with x plus 2 is the 4th root of that side and the 4th root of this side. If you do the 4th root of the quantity to the 4th power of x plus 2, you're just left with x plus 2. And on the right side, the 4th root of 625 is 5. And I'll show you on the screen over there how to come up with that. But this is a simple equation to solve from here. 5 minus 2 is 3. Log base 4 of 256 equals the quantity of x minus 3. So we should know that that means 4 to the x minus 3 power equals 256. Now remember, this is a base. 4 is a base. And 4 to some power equals 256. Some of these you can guess and check on. Plug in a 7, does that work? Plug in a 9, does that work? Some of these you can't do that on. So you have to know what to do. One way you can do this is to try to change this base. This is 256 to the 1st power. What we want to do is to change it to a base of 4. We need some exponent to put on that 4. Now, on your calculator, you can do 4 squared, you know, is 16. So 4 times 4 is 16. What if I multiply by another 4? What is that? 4 times 4 is 16, but if I times another 4, what is that? 64. And then times by another 4. What is that? 256. So 4 to what power is 256? 4. Yeah, because we multiplied 4 by itself 4 times. If you have the same base here as you have here, then the exponents are going to be equivalent. So x minus 3 would have to equal 4. So 4 plus 3 is going to give me an x value of 7. To solve this, you must know that it means 7 to the y power equals 343. And if I want to solve for y, then what I must do is put a log on each side. By rule, I can move that y down to the left of that log and come up with y log 7 equals log 343. And then divide the right side by log 7. Alright, so log 343 divided by log 7 is 3. If you have 3, come on up and claim it. This one is x to the third equals 216. And to come up with x equals a number, you must do the third root of both sides. When you do that, you'll find that x equals 6. This is 2 to the 8th power equals x. 2 to the 6th we already did today, that was 64. If you multiply that by 2, it's 128. And 128 times another 2 is 256. This is 3 to the 4th power equals x minus 3. 3 to the 4th power is 81. And we're going to move that minus 3 over to the left-hand side and make it plus 3. So the answer for x should be 84. This is equivalent to the quantity squared of x minus 7. This quantity to the 2nd power equals 36. So let's undo this square by doing this and just be left with x minus 7 equals 6, and move the minus 7 to the right. Make it plus, and come up with an answer of x equals 13. Like log base 2 of 32, notice that it's not an equation. But this must be equal to something. So you would think to yourself, 2 to what power is 32? 2 to some power x is 32. And this one is an easy enough one that you should know it is 5, because 2 to the 2nd is 4, to the 3rd is 8, to the 4th is 16, to the 5th is 32. You just multiply through by 2 until you come up with the right number. So you solve these just like you did the other ones. So if you see a log base 2 of 32, you can just make that a 5. And it's no different than this. Log base 4 of 256 is 4 to some power equals 256. And we've done this 256 before during this class. So 4 times 4 is 16 times 4 is 64, and times another 4 is 256. So x would have to be the fourth power. You can simplify a lot of these logs down to just one number. If you see log base 2 of 16 plus log base 3 of 9, it can be simplified down in most cases to a very simple addition problem. On the first part, 2 to some power is 16. And then 3 to some power, not necessarily x, we'll just make it y to keep it different, equals 9. Well, what power of 2 is going to give me 16? 4. And what power of 3 is going to give me 9? 2. 4 plus 2 is 6. So 6 is the answer to that expression. In this case, 3 to some power is 27. That's 3. And 2 to some power is 64. Well, that would be 6. And 9 to some power is 81. That's 2. So it sets up as an addition and a subtraction problem. 3 minus 6 is negative 3, plus 2 is a negative 1.